In this video now, I want to look at third rationalization. When is it necessary for us to rationalize third? And that how do we rationalize it? So that's what we want to consider here. First, we rationalize third once we see a sodic number in the denominator of a given problem. Once you see in the denominator roots something, alright, so you need to rationalize. Is that okay? Good. How do we now rationalize? We've got two methods we are going to apply here. Alright, we have the general method where we apply the conjugate of the denominator principle. Is that okay? And then we're going to also talk about the Omaka'S Udrl multiplication method. The Udrl there means up and down, right and left multiplication method. Of course, that's how we go about obtaining this formula that we use in solving third rationalization. Quickly, let us go through this general method. Is that okay? Let's go through that. For you to apply this general method, then you must know the conjugate of any denominator given to you. And that's why I've tried to bring out certain possible denominators and their conjugates. The first one we have is x root a. Remember, this x and a here, they are numbers. Y's, they're all numbers. So x root a, its conjugate, good enough, happens to be the same x root a. That's the simplest form. Then we now have the next one, y plus x root a. What's the conjugate? All we need to do is to change the sign of one of these two terms. Either you change the sign of y, then maintain the sign of x root a, or you change the sign of x root a and then maintain the sign of y. That's why, look at this, we have y, I maintain the sign, and then came to this plus and change it to minus. So x root a. Or you can do minus, change the sign of y, then maintain plus x root a. Take note that this plus could also be minus. If it is minus from here, then taking the conjugate, like as in this case, this minus become what? Plus. That is if you maintain the sign of y. And if this is minus, then here, changing that of x root a to become plus here. Is that okay? Alright, now the next one we have x root a plus y root b. So if you have x root a plus y root b, what's going to be the conjugate? The same thing. Change the sign of one of them. So in the first case, I chose to say, okay, I maintain x root a, then change the sign of y root b. And you can see that it becomes minus here. Or you maintain the sign of y root b, look at it, plus y root b, then change the sign of x root a, which becomes what? Minus x root a. So once you get this conjugate, the next thing to do is to multiply the numerator and denominator of the given sodic fraction by these conjugates, and then start simplifying. You'll surely get your result. We now consider the Omaka'S up and down, right and left multiplication method. Okay, so this is it. Okay, it's a formula, so it's expected that you memorize it. But let me show you how it actually came about. Just imagine that we have a and then plus b root c. You have to go in this pattern. I'm going to show you, please. Remember, it's a principle, and so you need to follow it. Okay, so that you don't get into trouble. So this is how we go. The up and down multiplication, the first direction is a times d, up and down. So we have a times d, that's the first multiplication direction, and that's going to give us ad. Then minus, you come to this term, another up and down multiplication, which is b root c times e root f. b times e, and then times root c times root f. Look at that. This is the second direction of multiplication. And that is going to give us b times e is be, then root c times root f. Using multiplication law of SOR will give us root cf. So we get be root cf. You can see that here, right? So once you are done with the up and down multiplication, and close it in bracket, put plus. Then move to right and left multiplication direction. And in the right and left, what do? Watch. You go this way, this is your right. So from there, you come down this way. And then your left, you come down this way. Remember, from up, down. Is that okay? So you go right up and then down. Right, left, and then down. So that's the principle. Remember, like I stated, you are expected to follow the principle if you want to use this method. Good enough. This method is faster to obtaining results than using this method. Okay? That is the Omaka'S Udrl method. Is faster than using the conjugate of denominator method. Okay, now let us go. The next we stated, that's the third direction of multiplying, is this. And then if you multiply b root c with this d, you're going to get b times d, which is bd, and then root c. Then put your minus, and then go your last multiplication, which is left to this way. There is the fourth direction of multiplying. Is that okay? If you multiply a times e root f, you get a e root f. Look at it. Does that make sense? Then all over the denominator is a simple one. Square this term, square this other term, then put minus between them. If you take the square of e root f, you're going to get e squared, which is this, then square of root f. That square would remove this square root. So that is the Omaka'S Udrl multiplication method of solid rationalization. In the next video, we shall pick questions and then we should apply all the laws that we've written so far about solid. Oh yeah, now we want to look at this question on the board. Okay, we are going to apply two methods as an alternative to solving this problem. We are to simplify 4 all over 3 plus root 5. Now you take note that in the denominator we have a solid number, so we need to rationalize this. And because in the denominator there are two different terms, okay, we have 3 and we have 5. We have root 5. It means that we can solve this problem either by using the general conjugate method or we can use the Omaka'S Udrl multiplication method. First, let's go by the general method. Now we're given 4 all over 3 plus root 5. So we're going to write by the general method. By the general method, now we're going to find a conjugate of the denominator. By the general method, conjugate of 3 plus root 5. Conjugate of 3 plus root 5 is, I want to choose 3 minus root 5. So I've decided to change this sign while maintaining plus 3. Is that okay? Take note, one might choose to change this sign to minus 3 and then maintain this plus root 5. Okay, so we are going to multiply the numerator and denominator of our given surd by the conjugate of the denominator. So this is going to be, this is the problem we're solving. It's going to be 4 all over 3 plus root 5. So we're going to multiply this, let me enclose this in brackets. So we're going to multiply this by 3 minus root 5 all over 3 minus root 5. Once again, I have committed no crime here because of course this 3 minus root 5 over 3 minus root 5, the conjugate can actually divide through to give you 1. 1 times this bracket will still give you back what we were given as a question. Now at this point, we are going to open up the bracket. So this is going to be 4 times 3, which will give us 12. So this is equal to 12. 4 times 3, you get 12. Then 4 times minus root 5 would give us minus 4 root 5. Does that make sense? Then come to the denominator. The denominator is always difference of 2 squares. The denominator is always difference of 2 squares. Simply come to this term, pick the 3, square it, pick the root 5, square it, and then put the minus between them. Please take note of this. You can even put it down beside the writing in your note. Okay? So I really don't want to look at it as if punishing myself. Going to do 3 times 3, 9. 3 times minus root 5 will give us minus 3 root 5. Then root 5 times 3 will give us plus 3 root 5. And then root 5 times minus root 5 will give us minus 5 as our result. Of course, 3 times minus root 5, which will give us minus 3 root 5, and root 5 times 3, which will give us plus 3 root 5, they will cancel out without expansion. So you see now that you'll be left with 9 minus 5. So please take note of this. The denominator is always the difference of 2 squares. You can even see that exactly what you have in the denominator here is what you have here. Is that so? The only difference is the sign. So it's difference of 2 squares. Therefore, I will pick this part. I'll write 3, then I'll square 3, put my minus, come to this root 5, and then square it. Root 5, and then I'll square it. Okay, so this is going to give us 12 minus 4 root 5 all over. This is going to give us 9 minus 5. Therefore, okay, so we're going to get, can still work this through 4 root 5, then over 4. you know that this can be splitted. We have 12 over 4 minus 4 root 5 over 4, which this 4 can divide this 12 to give us 3. 4 and this 4 will go off to give us 1. So we'll be left with 3 minus root 5. So you can conclude that 4 all over 3 plus root 5 is equal to 3 minus root 5 as our result. So this is the answer to this problem. Now we will take a short break. When we are back from the break, we're going to use the Swift method, the Omaka'S Udrl multiplication method, to solve and obtain the same result. You are welcome from the short break. So this time around, I want to solve this same question using the Omaka'S Udrl method, multiplication method. So this is 4 all over 3 plus root 5. Okay, so I'm going to write using Omaka'S Udrl multiplication method. So let's see how this goes. Multiplication method. So you watch now. One thing we want to do is to complete a term in the numerator. We want to have two terms, both in the numerator and the denominator. So I'm going to write this as 4 plus, okay, let me bring up my hand this way, 4, so I'm going to put plus 0. Is that okay? To make it two terms in the numerator. Then the denominator, I'm going to have 3 plus root 5. Is that okay? Okay, now this will be equal to, so we start, remember your first movement, up and down multiplication, you go this way first, and then you go this way second. Does that make sense? Then you come this way. Anyway, let's show up the result here first. 4 times 3 is going to give us 12, so we're going to write 12 minus 0 times root 5 will give us 0, so we are done with that part. You know, get this up and down, put minus between them. Then plus, open brackets, this time around we're going to go right and what? Left. So this is going to be this way as the third direction of multiplication, this way as the fourth direction of multiplication. So let's do this. 0 times 3 is going to give us 0. I'm going to put 0 here minus, then 4 times root 5. 4 times root 5 will give us 4 root 5. Then all over, come to the denominator. Remember, it's always difference of 2 squared. So square this 3, you're going to get 3 squared. Then minus square this, you get root 5 squared. And that's all, you know, so we can conclude that for 4 all over 3 plus root 5 is going to give us, if you work in this, 12 minus 0 will give us 12. Come to this part, 0 minus 4 root 5 will give us minus 4 root 5 in the bracket here. So plus times minus changes to minus, we'll have 4 root 5 all over 3 squared will give us 9. Root 5 squared will give us 5. So this is 9 minus 5. Alright, and then if you work out this, you have 12 minus 4 root 5 all over 4. And as usual, you can split. Okay, you can split, divide this, and then we could get that 4 all over 3 plus root 5 is equal to, this 4 divides this 12 is going to give us 3 minus 4 divides this 4, you get 1. 1 times root 5, you have your 3 root 5 as before. Remember, we used the conjugate method, the general method, and we obtained this. So this shows that both methods can work for all such type of question. We will be consistent with using the Omaka'S Udrl multiplication method here from the GMAT 41. We now want to solve this problem. We have question number 6. We are to express 3 root 2 plus 2 root 3 all over 3 root 2 minus 2 root 3 in the form a plus b root c. Then a comma b comma c is given us, we don't know. So we're going to find out. We want to get the value of a comma b comma c. Now look at this question. I could have simply said that if 3 root 2 plus 2 root 3 all over 3 root 2 minus 2 root 3 is equal to a plus b root c. Find the value of a comma b comma c. That's just what the question is about. So please be guided by what we're going to do in solving this question, Then at the end of that, do test your zone of proximal development by solving this problem. You're given this sort and it's equal to x plus y root p. So you're expected to find the value of a, and a here is x comma y comma p, just like we obtained a comma b comma c here. Are you following, right? So just get the value of x, y, p. Then the second part, you are to get the value of b such that b is equal to minus 5 times the value of y you're going to get from here divided by 2. Is that okay? So let us solve this so that you'll be guided by that in solving your own question. Solution. So let us look at the sort given to us. The sort given is 3 root 2 plus 2 root 3 all over 3 root 2 minus 2 root 3. We are going to use, alright, we're going to use the Omaka'S Udrl. So using Omaka'S Udrl multiplication method. Remember, I told you that I will be consistent in using that method in rationalizing sort, because it's quicker to use it in getting the value by sort rationalization. So let's go. You know, the principle is going to give us 3 root 2 plus 2 root 3 all over 3 root 2 minus 2 root 3. So this is equal to, your first direction is what? Up and down. So this is the first multiplication. This is going to be the second multiplication. So let's do this and see. We're going to have 3 root 2 times 3 root 2. This is the same as 3 times 3, which is going to give you 9. Then root 2 times root 2 will give you 2. Is that okay? So this will become 9 times 2. That's the result of 3 root 2 times 3 root 2. First, this 3 will multiply, gives you 9. Root 2 will multiply to give you 2. 9 times 2 will be equal to 18. So I'm going to put 18 here, then minus, come over here and do same. 2 root 3 times minus 2 root 3. So we go as 2 times minus 2 will give us minus 4. Is that okay? 2 times this minus 2, because this is minus, you know. It's going to produce minus 4 for us. Then root 3 times root 3 will give us 3. Minus 4 times 3 will give us minus 12. So I'm going to write minus 12. Alright, I've chosen to use blue marker for that. So I will add these results to, let's see what we'll get. This time around we are going right and left. So we go right, this will be the third direction of multiplication, and then we go left. Okay, this will be the fourth direction of multiplication. So we go 2 root 3 times 3 root 2. Once again, 2 times 3 will give us 6. Then root 3 times root 2 will give us root 6. Remember, because this 3 will multiply this 2. Multiplication law of sort. So this gives us 6 root 6. So we'll have 6 root 6. Then minus we go left way. 3 root 2 times minus 2 root 3. So we go 3 times minus 2 will give us minus 6. So I'm going to write that here, minus 6. And then root 2 times root 3 would give us root 6. Good. So we are done multiplying up and down, left and right. Take note, this is subtraction, okay? Now, I'm going to divide all this by the difference of two squares in the denominator. So come over here and square this term. Okay, if you square this term, you're going to get 9 times 2. You know what that means? We've done that separately. Square this, you get 9. Square this square root will disappear, you'll be left with 2. So 9 times 2 is 18. Then minus, come over here, square these 2. When you're doing the square of each of the terms in the denominator, don't go and use the square to affect this minus. Is that okay? Just the numbers only. Then you put minus between. 2 square will give us 4. Then root 3 square will give us 3. 4 times the 3 is 12. Good. So we're done with this. So we can now simplify further. 8 minus minus will give us plus 12 there, which is 30. So we'll have 30. Then look at this. 6 root 6 minus minus will give us plus. So this is 6 root 6 plus 6 root 6. The acidic parts are the same. Take note of that. The acidic parts are the same. Root 6 root 6. So you can actually add them up. So you get 6 plus 6, which is 12. Alright, and then you pick one of the root 6. So this will be plus 12 root 6. We shall divide this by 18 minus 12, which is 6. And of course, you know that this will give you 30 over 6 plus 12 root 6 over 6. The result of this will give us that 3 root 2 plus 2 root 3 all over 3 root 2 minus 2 root 3 will be equal to, come over here, then do your division. 6 into 6 is 1. 6 will divide 30, you get 5. Then 6 here, 1. 6 here, you get 2. So this is going to give us 5 plus 2 root 6. So you see, we've expressed this in the form of, okay, let me write it here, in the form A plus B root C. A plus B root C. So we can now conclude, therefore, we can pick the value of our A, comma B, comma C from it. So A, comma B, comma C will now be equal to, so let's find out. We are now going to compare these results to this. So our A is the part that has nothing to do with the root sign. Is that okay? So you compare here, you notice that 5 is the number that has nothing to do with this surge. So A will be equal to 5, then comma B. Come over here, B is the multiplier of this surge. So you come to this, 2 is the multiplier of this surge. So B is 2. And then C is the term that is enclosed by the root sign. Come over here, 6 is that term enclosed by the root sign. So C is 6. And this is our result, answer. So please use this procedure to solve this problem, get X, Y, and P, then proceed to obtain some other things you're asked to find. Of course, like here, imagine I was asked to find 5 times B divided by 10. It will be 5 times the value of B, which is 2, then divided by 10. And that, of course, will give me 1.